Welcome to another video. This is bond pricing and interest rate determination 7. Okay, so I just want to fill you in on some stuff you might need to know to make the yield curves spreadsheet easier for you to work with. And again, what we're dealing with is the following with spot rates and the zero coupon yield curve. So we assume that we have these dates, which are the maturities for a 1 period, a 2 period, 3 period, 4 period, and a 5 period Treasury securities. Okay, and we've talked about how we can calculate forward rates. There's F2, F3, F4, and F5. Let's put some values: 7, 8, 9, 10, and 11. These are all percents. Okay, percentages. And like I said, this is F sub 2, F sub 3, forward rate over the 4th period, forward rate over the 5th period. And just to remind you, the forward rate over the 2nd period is just the interest rate someone would have to earn between date 1 and date 2 if they'd already locked in 7% for the 1st period. So you kind of 1.07 times 1 plus F2 would then have to equal the value per dollar invested that someone would have at day 2 if they originally locked in that 8% per period. So this is it. When you do the algebra, you get F2 equals 1.08 squared divided by 1.07 less 1. Okay, I think that's 0.0901, something like that. Okay, and so we get the forward rates. You can also see, like you might say, well, where does F3 come from? Well, you just ask a similar question. You say, let's say someone locked in 9% for each of 3 periods. Here, change the color here to green. Say someone locked in 9% for 3 periods. So you know they're going to have, for every dollar they invested, they're going to have 1.09 cubed at day 3 if they hold it to the maturity. And so you ask a question. You say, well, assume someone locked in 8% for the first 2 periods, kind of like being this guy here. And then what rate would they have to earn between date 2 and 3 to end up with 9% per period? So 1 plus F3. Okay, and lo and behold, you do the algebra, you get F3 equals 1.09 cubed divided by 1.08 squared. 1.09 cubed divided by 1.0 squared less 1. I told you before that the formula of the forward rate over the nth period is 1 plus the n period spot rate to the nth power divided by 1 plus the n minus 1 period spot rate to the n minus 1 power less 1. Okay, so you've seen that. And that's kind of how we get our forward rates. One thing that's very interesting is you should know that someone who at date 0 locks in the 5 period spot rate, for every dollar they invest, they'll have 1 plus that 5 period spot rate to the 5th power. In the current case, they'd have, for every dollar they invest, they'd have 1.11 to the 5th power at day 5. Okay, but this is equal to 1 plus the 1 period spot rate. I lost my 1 there. I'll put it back. There we go. Times 1. Oops. Get the eraser here. Sorry. Wait. Times 1 plus F2 times 1 plus F3 times 1 plus F4 times 1 plus F5. Okay, so that's equal to that. Okay, in other words, this shows something that's actually very important. It shows you that if you lock in a 5 period spot rate at date 0, what you end up doing is earning all those forward rates, okay, each period through time, which is equivalent during that 5 period spot rate. And that's a big deal. You'll see why in a second, okay? So once we have these forward rates, I'll go back up here to my little picture here. Once we have these forward rates, then we can figure out what the expected future zero coupon yield curve is at date 2. So, excuse me, at date 1. So here's date 1. So I'll go up here and I'll go, there's that, there's 2 period, 3 period, trying to come down to where the 4 is. And there's the 4 period. You know, if I start at date 1 and I've only got data through date 5, the expected zero coupon yield curve expected to be in existence at date 1 can only have 4 values. And then again, just to kind of refresh your memory on some of this stuff, here, the zero coupon yield curve expected to be in existence at date 2 would be, there's the 1 period, the 2 period, 3 period, and then the zero coupon yield curve expected to be in existence at date 3 is just like this, 1 period and then 2 period, and then the expected zero coupon yield curve expected to be in existence at date 4 is just, you know, there's just 1 period left at that point. And so these things up here is what I want to talk to you a little bit about now. And the values that we get from these, for these, are based upon the forward rates. And let's just focus on one, okay? Let's focus on this thing right here, okay? So that is the, it's a, you look here, you see, it's a 3 period spot rate expected to be in existence at date 1. I use a superscript, just my notation. It's the 3 period spot rate expected to be in existence at date 1. And the little trick to this is to see that, well, kind of look here. This runs, I'll use a different color here. I'll use yellow. No, I can't use yellow. Sorry. I'll use this color. Okay, so this runs from there to there, as you can see. And now the important thing you realize is that it involves F2, F3, and F4. So we can then say 1 plus the 3 period spot rate expected to be in existence at date 1, okay, cubed would then be equal to 1, again, just showing you. It goes from here to there, so that involves F2, F3, and F4. And so would have to equal 1 plus F2 times 1 plus F3 times 1 plus F4. Would have to, okay? Because of our assumption that the pure expectations theory is correct and complete. Okay, now you can see when you solve this, you're going to take the cube root of both sides. So here you're going to get 1 plus the 3 period spot rate expected at date 1 is equal to the cube root of 1 plus F2 times 1 plus F3 times 1 plus F4. Okay, and then of course, 3 period spot rate expected to be in existence at date 1 will equal the cube root of 1 plus F2 times 1 plus F3 times 1 plus F4 minus 1. So that's where that came from. I spoke of that in the videos. There you can see that's where it comes from. That's how the algebra works. So we can build expected future zero coupon yield curves based upon that big assumption that the pure expectations theory is correct and complete. Okay, this is a really nice visual. Kind of key. Well, sorry, I should have made that bigger. This is a very nice visual. I encourage you to. Kind of store this in your mind if you can. Okay, that's kind of what's going on here. So, all right, let us now consider, but the pure expectations theory isn't correct. Let's look at the liquidity premium hypothesis, or liquidity preference. I'll use the word preference. They're both, the idea is the same. Liquidity preference theory. Call it a theory instead of a hypothesis. Basically the same thing. And what's that say? Very simply, it says that the forward rate over the second period does not equal the 1 period spot rate expected to be in existence at date 1. It also says the forward rate over the third period does not equal the 1 period spot rate expected to be in existence at date 2, and so on. Okay? And it offers more specificity. Okay? It says that the forward rate over the second period is equal to the 1 period spot rate expected to be in existence at date 1 plus some liquidity premium I'll call L. Okay, a little subscript on it. It says the forward rate over the third period is equal to the 1 period spot rate expected to be in existence at date 2 plus some perhaps different liquidity premium L2. And that's the liquidity preference theory that makes a big observation. And what is the observation? So here I'll switch to red, and I'll focus on this one right here, and I'll draw an arrow down. And what this implies, okay, this implies that the 1 period spot rate at date 1 is equal to the forward rate over the second period minus that liquidity premium. And so this makes clear, here's the biggie, right? This is the biggie. This implies that the 1 period spot rate expected to be in existence at date 1 is less than the forward rate over the second period. Okay? And remember how I said up here that when this guy locked in 5%, how he locked in all these forward rates, if he held it for 5 periods? Now you can see why that's a good thing, because if he just makes a bunch of successive 1 period investments, he's going to earn a rate per period that's less than the forward rates. But when you invest in a long-term maturity treasury strip, then you lock in those forward rates. Understand that. That's a big deal. Okay. So this is true. I'll switch the color here for a second. So this is true, of course. And then also we can say the 1 period spot rate expected to be in existence at day 2 is less than F3. And the 1 period spot rate expected to be in existence at date 3 is less than F4, and so on. Okay, so if you understand that, you're doing very well. But it is very helpful to be able to use the yield curve spreadsheet to get an idea of how we can estimate all these values up here. Okay, that's important. Then all we have to do is adjust the values we arrive at. For example, just adjust it to reflect liquidity premiums. Okay, we have to, figure out what L1 and L2 are, and that's for a more advanced course, but it's not a complex concept. Okay, and I guess that's all I have to say specifically about that spreadsheet. Just keep in mind that the analysis in the spreadsheet is assumes that the pure expectations theory is correct and complete. And you're also aware from other classes that there's a preferred habitat theory that says, investors may prefer to be in a certain maturity field. Maybe certain types of insurance companies like to have investments in bonds with maturities between 5 and 7 years, just for example. But they'd leave that preferred habitat if yields were sufficiently high And so that's just reminding you of something you had in other classes. The third aspect, the preferred habitat theory. So again, in summary, the three main interest rate determination theories are the pure expectations theory, the liquidity preference theory, and the preferred habitat theory. And so we focused mainly here for algebraic purposes on the pure expectations theory, but we also recognize that the liquidity premium hypothesis is very correct and powerful. And people do not like illiquidity, and they do like liquidity. And the issue with liquidity is that if someone might invest in a 5-period treasury strip, and let's say something happens at day 3, they need the money. They hadn't expected to need the money, but they do. Then the price at which they're going to have to get out of that investment is going to depend upon what, at date 3, say, is going to depend upon what interest rates are at that point in time for the next 2 periods, which would get to the original date 5 when the security was going to mature. So that uncertainty is what makes people like liquidity. And when they give up liquidity, and they do so by investing in longer-term maturity treasury strips, they expect to be compensated for that. Okay, and I guess that's all for this video. Thanks for watching.